Welcome back to some more finite. Today we're talking about lesson 4.5, which is the general multiplication rule and tree diagram. So on the right, you can see kind of an example of that tree diagram, kind of anyway. We'll talk a little more about that when we get there. So here are the objectives for today. I suggest you have your notes out so you can write them into your notebook, and I'm going to go over them real quick while you do that. So you got the general multiplication rule, and we're going to use that to calculate some probabilities today. We're going to find out what a tree diagram is, involving how to model a process as well as calculate conditional probabilities using the tree. So, again, here I'm going to introduce, again, the general addition rule, something we know very well by now, hopefully. It is used when you're trying to find out the probability of two events occurring either or. So either both of them are occurring or one or the other is occurring. Or this, we have this P of A plus P of B minus the intersection. That's the AND part. So we've used so far two-way tables and Venn diagrams, but what if you just want to find this piece right here? Okay, well, what if you want to know what this piece is? Well, that's how we can use the general multiplication rule to find our probability. So here is that general multiplication rule. For any chance process, the probability that events A and B both occur can be found using this rule. The probability of A and B is the same as probability of A times the probability of B given A. Okay, so this is kind of our conditional probability. Hopefully you learned about that last time. Okay, where event B occurring, given that A already occurred, is the piece right here. Okay, well, let's just take a look at this a little further. If you actually notice, this is actually from the conditional probability formula, and let me show you how. Okay. So first of all, let's take a look at our conditional probability formula. It says that P of B given A, okay, is the same as the probability of B and A all over the probability of A. Okay. Well, there's something special about this formula. It's that this part right here, the P of B and A, can actually also be the same as P of A and B, since, well, if they both happen at the same time, that should follow that they're both okay to be written that way. And you can also do this with OR, technically, although I think there's a little bit of difference there. Okay, so P, A, and B is the same as P, B, and A, okay, for all things in this. So when we reorganize the formula, we get that P of A and B is the same as P of A times P of B given A. All right, and that's it. That's really it. Okay. All right, so let's take a first look here. About 55% of high school students participate in a school athletic team at some level. Roughly 5% of those athletes go on to play a college team in the NCAA. So what's the percent of students that play a sport in high school and then go on to play in an NCAA team? Well, first we have to take a look at our two probabilities that were given here. We have 55%, okay, and 5%. Okay, and there are two events also. Okay. The event that they participate in a school athletic team, we can call this our A. And then there's another event, they play in a college team, we can call this our B. So what is exactly the formula again? We'll take a little look. We're trying to find out what the probability of A and B is. Okay. And using our general multiplication rule, we know that it's the probability of A, that would be our 55%. Whoops, I need to start with A first, times our probability of B given A. Okay. So this is 55%, which is 0.55, times our 5% of those athletes, so it's 0.05. Remember, you gotta move the decimal point in an appropriate manner. And once you do all that, they should end up being 0.0275. Which, if you translate back to a percent, is a 2.75%. Does that make sense here? That means that about 2.75% of all high school students will do both of these things, because we know that 55% of them play on a high school team, and then 5% of those people go on to play in the college team. All right. So let's give you a shot at this type of problem. Okay, I'll give you a chance to look at this and then give it a shot. All right, we're moving on to the tree diagrams. So hopefully you got enough practice with the multiplication rule. I think it is really pretty simple. The tree diagrams, okay, are things you've probably seen before. They are a visual way to describe probability models, but they're used mostly to highlight conditional probability. So that's why we waited till now to really show them, although you've probably seen them being used here and there. But it basically shows you the sample space of a chance process where there are multiple stages. Think drawing 2 cards in a row, rolling 2 different dice, flipping a coin over and over again, those kinds of experiments you can model with this tree diagram probably a lot easier than just listing all the possible outcomes. So another thing to note is that all probabilities after the first stage, the first little branch, are conditional. So keep that in mind as we move forward. Here is our example. So let's say we have a student named Shannon, and on 60% of school days, Shannon will hit the snooze button. I'm sure most of you probably can relate. I definitely can as well. And if she hits the snooze button, there's a 70% chance she will make it to period 1 on time. 30% chance she'll be late, obviously. So here is the tree diagram modeling this process. You can see here that, let me use my little highlighter. Okay. You can see right about here that this is the event A, right, where she hits the snooze button. Okay. And then here is event B, use a different color, where she's on time. Okay. This, you can also see that here is the probability where she hits snooze and is on time. Okay. Well, rather than and, it is she's on time given that she hits snooze. So using these, you can kind of see this is the probability that's conditional. This is like the probability that's part of it. And if you want to find out the product, the chance that she did either of these, both of these things, you just have to go down the branches. Same can be said for any of these other pieces here too. So, what's the probability that Shannon hits snooze and is late for class on any given day? Okay, well, for this, we're going to need to use our general multiplication rule. I kind of spoiled it a little bit, but hopefully you can take a look at this drawing, and this is this diagram, and say, okay, here's my given probability, B given A, right? B given A, and then here's my A. So what we need to do is have probability of A times the probability of B given A. That is, of course, 0.6 times 0.7, which is 0.42. So about a 42% chance that, I guess it's the other way around, and is late. So I guess I messed that up. My bad. Okay, but this is supposed to say not late. Okay, sorry. Okay, not late. It would be 42%. You know that this happens because of this. But since this happened, you need to also accommodate for this chance. That's why we use the multiplication rule. Okay, but then how about this? How about this? What if you want to find the probability that they are simply late to class? So we don't really care about whether they hit the snooze button or not, but we do care about if Shannon was late in general. Now, this is really nice about the tree diagrams, is that it lists every possible outcome for every possible previous outcome. So here's our level 1 outcome. Here's our level 2. So remember, these are conditional. But right now, we're finding out if they're late to class. That's our event. So let's just take a look at the events in the branches that qualify for our late to class bit. That would be this one right here and this one right here. Okay. So if she's late to class, that's it. Okay, we don't care about whether she hit the snooze button. We don't care about whether she didn't hit the snooze button. We only care about if she's late. So we need to figure out how much percent this is and how much percent this is, and then just slap them together. Okay. Remember, there's no overlap here, so you don't need to worry about using general addition rule. Okay. But 0.6 times 0.3. Okay, that is 0.18. And on the other hand, we have 0.4 times 0.1. 0.4 times 0.1. That is 0.04. Okay. And if you add these two things together, you'll get 0.22 as the final chance that Shannon is just late to class no matter what. Alright, so now it's your turn to try this out. Using the same diagram, I'm going to ask a couple of questions here about this probability, where there's a probability that Shannon is on time and did not hit the snooze button. I'd like to know what that is. And then what is the probability that Shannon is just on time in general? Give it a shot. Come back to the video when you finish. So here we are at the end of the notes video. Hope it wasn't too bad. But after this, if you can, use the general multiplication rule to calculate probabilities, use a tree diagram to model a chance process, and calculate conditional probabilities using tree diagrams. You are totally set for class, and we will see you then. And come with class with any questions you may have. Okay, ready to learn more about this tree diagram stuff. See you then.